In this video, we are going to talk about problem 9.118 from our textbook, dirt bikes. It says dirt bikes are simpler and lighter motorcycles that are designed for off-road events. Specification for dirt bikes can be found through Motorcycle USA on their website, www.motorcycle-usa.com. A random sample of 30 dirt bikes have a mean fuel capacity of 1.91 gallons with a standard deviation of 0.74 gallons. At the 10% significance level, do the data provide sufficient evidence to conclude that the mean fuel tank capacity of all dirt bikes is less than 2 gallons? Okay, so we're performing a hypothesis test. One thing that we need to decide is what type of test is it, a z-test, right, or a t-test? And in this case, right, the deciding factor is, do we know the population standard deviation? The answer is no, that's not given. We do know the sample standard deviation, right, is 0.74 gallons. Okay. You can see it says a random sample of 30 dirt bikes have a mean fuel capacity of 1.91 gallons with a standard deviation of 0.74 gallons. And you may say, hey, well, wait a second, that's a little bit confusing because, they just say standard deviation. They don't tell us whether it's a sample standard deviation or a population standard deviation. And the thing is if it's the population standard deviation that they're talking about, they have to put population standard deviation in these problems, right? Because otherwise it's ambiguous as to, what we're talking about. So they are talking about the sample standard deviation here, okay? All right, so now we know we are using the t-test. We're going to run through the t-test, one mean t-test procedure, right? The first thing is to determine the null and alternative hypotheses. So looking through the problem, it says at the 10% significance level, do the data provide sufficient evidence to conclude that the mean fuel tank capacity of all dirt bikes is less than 2 gallons? All right, so that's what we're testing, right? Whether the mean is less than 2. That means that our null hypothesis is going to be that mu is less than 2. That makes, our alternative hypothesis is that mu is less than 2. That's going to make our null hypothesis mu equals 2. Okay, next up is the significance level. They just flat out tell you, right, in this problem, like they will in all the problems that will work, that it's 10% significance level. So as a decimal, right, that would be 0.1. All right, next up is to calculate the test statistic. So that's going to be t equals x bar minus mu naught all over s divided by square root n. X bar is our sample mean. They say that the sample mean is 1.91, so mean fuel capacity of 1.91. Mu naught is this number that's with the null and alternative hypothesis. S is our sample standard deviation, so that's going to be 0.74. And we're going to be dividing by the square root of the sample size. Our sample size is 30, right? It says a random sample of 30 dirt bikes. So we're going to divide by the square root of 30. And we're going to need to calculate that out. So 1.91 minus 2, 0.74 divided by the square root of 30. We get minus 0.67 to 2 decimal places. Okay, let me write that down, minus 0.67. All right, next up we are going to calculate the p-value. This is a left tail test, right? And we are looking, so that means we are looking for the area, right, that's to the left of minus 0.67. Okay. Um, our table, right, table 4 only gives the area to the right, but we know that this t distribution is symmetric, and so therefore if I find the area that's to the right of 0.67, right, this is what table 4 is going to give us, right? This area over here to the right, because the t distribution is symmetric about the mean, that means that this area over here to the left is going to be exactly the same as this area over here to the right. Okay, so before we do that, we'll need the degrees of freedom, right? So the degrees of freedom we know is 1 minus the sample size. So our sample size is 30. So our degrees of freedom, 29. All right. So what we'll do is go look on the row corresponding to 29 degrees of freedom. That's right here. And we are looking for a t value of 0.67. Okay. So 0.6729. All right, and we can see that the first number right here, right, is 1.33. So 0.67 would be over here to the left, right, of this first column. All right, so if I go up and look, that says, right, that our p-value is bigger than 0.1. Okay. If you look at the way the table's organized, right, the p-values are getting of these numbers, subscripts up here on this top row, are getting bigger, right, as they go to the left over here. Not the t values themselves, but these p values up here, right? So our value is going to be up here on this side over here, and therefore be bigger, right, than 0.1. All right, so that's enough to be able to compare the two, right? Next thing I want to do is compare our p-value and alpha and decide which one's bigger. Our alpha is 0.1, right? And our p-value is greater than 0.1. That's the information that we got from the table, right? So therefore, the p-value is greater than alpha. If the p-value is greater than alpha, then we do not reject the null hypothesis. And our statement, right, our interpretation is going to be the data do not provide. Oops, didn't mean to do that. So the data do not provide sufficient evidence to conclude that the mean fuel tank capacity is less than 2 gallons. All right, and where did where did that come from? It came from the alternative hypothesis, right? And these are always going to be, right, that the date it's less than the or less than whatever the alternative hypothesis is, rather, right? In this case, it was less than 2 gallons. Okay. All right, that's it on this one.